So you will be able to see it on YouTube if you need to. There we go. Here's. So if you need a computer, please take it from you. Just do it so we don't disturb the class. So let's quickly review. In your exam, and you have reviewed for the exam, so you know really well how to actually solve a system of linear equations by hand. We can either go to Gaussian elimination, and that's typically we do that if we are solving the system only once. If I'm expecting to solve a system Ax is equal to b multiple times with the same coefficient matrix A, just I'm changing these, and that happens often in numerical modeling. You will set up your coefficient matrix, and that sort of depends on the physical components of your setup. If those are coefficients, like for instance, if you're flowing through tubes and so forth, then basically how much flux you can push through those tubes depends on the geometry of tubes, and that's something that goes into coefficient of the matrix A. And stuff that would go into that right-hand side B are typically boundary conditions, so pressure differences that you impose and so forth. So if you wanted to solve for the same system, same physical system, just under different boundary conditions, you would have to solve Ax is equal to b with the same A multiple times, just changing that right-hand side B, in which case you would do LU decomposition. Now all of that's really nice, and it works rather well for relatively small systems. And when I say relatively small systems, there's a system that's less than 1,000 unknowns, so basically less than, my A is less than 1,000 by 1,000. For anything bigger, Gaussian elimination piles up way too much numerical error, and also it's slow. Okay? So we actually turn to so-called iterative methods. Okay? They're not geared towards finding an actual, real, close to analytical solution, but they basically iterate and hopefully get close to the solution, and how close depends on your tolerance. So basically, how do we do that? One simple idea that actually led to a lot of methods that we use is, okay, I have a system of equations. I can just rearrange it, similar like that fixed point iteration. Okay, where I arrange or rearrange my f of x is equal to 0 to something that is like x equals to g of x. Okay, so I do the same with this system. So basically, if I manipulate this system, I can express x1 from this first equation. And if I do that, I will get the second one. So I will say, okay, x1 is b1 minus this sum that was on the left-hand side and divided by a11. So I do the same for x2 from the second equation. I do the same for x3 and x4 if this is a 4 by 4 system. Okay? So that gives me something that I can use to iterate. I start with a starting guess. Every time we iterate, we start with a guess. The most easy one is 0, 0, 0, 0. So I set my vector initially to all zeros. Okay? So if I do that, for instance, here, basically, I will set all of these to zeros, and I will get my next iteration to be b1 over a11, b2 over a22, b3 over a33, and b4 over a44. As a matter of fact, this is what we did basically in that example that we did by hand. If you remember anything that happened before exam on Monday, then we actually had this example by hand where I put my zeros in, and I got my first x1, x2, and x3. Okay. And then once I have that vector x, I'm going to call it vector x that has 3 numbers, I can plug it into that same iteration and get my next guess. So now there will be a little more calculations because these will not be 0 necessarily, but I will do that again. So does anybody need to review how this was done by hand? So we understand basically that so the way I iterate, okay, is I start with a starting guess, and then I plug in that guess into my right-hand side, and that gives me my next guess, okay? And I do that in a loop, okay? So then I have that next guess, let's say this guess 2, I can plug that into the same right-hand side again, and do and get the third guess. And then third guess I plug into my right hand side. So all of these x1, x2, x3, x4, I plug in my current guess and I get next guess by doing this. So since I want to repeat that multiple times, what loop is ideal for programming that? For loop. Okay. So I'm gonna do for loop, okay, to actually go through getting all of this. Okay. But then when do I stop if I do for loop? So I do for loop to compute all of this x1, x2, x3, x4. Okay.
All the common stuff.
So, but when will I stop? So I have my guess 1, guess 2, guess 3, guess 4. I keep iterating and keep getting these guesses. When is it? When do I think I'm close? When do we stop the root finding? Huh?
Could you use if the error is greater than whatever your tolerance
So I'm going to
is?
keep doing that while error is greater than tolerance, and tolerance is something that you set. Okay? So we had this in root finding, my tolerance was 0.001. Okay? So while my error is larger than 0.001, I keep doing this. I set up a for loop that goes through all of these elements of it and computes them from my previous guess. Okay? And actually this formula here, it looks complicated, but we know everything about it. This basically just writes down one equation that is valid for all of these x's. So my xi, which used to be 1, 2, 3, 4 here, okay, is my bi minus that sum that goes over all of the aij, xj, except for the one equals to I. Okay. And then I compute this. This is basically that. Okay. And once I compute that, then I just divide by aii. Okay. And I do this in a for loop for every I from 1 to n. So this is what would be one iteration that gives me my next guess from old guess. So this 2 to k refers to my old or previous guess, and 2 to k plus 1 is my new or my current guess. Okay. So everybody has some idea how you would program?
So it's like a for loop inside, or while loop inside a for loop.
So for loop would be to get all of these xi's, right? So I would do for loop. Okay. And then, but that gives me only one vector, right? That has n elements. And now I'm figuring out when do I want to stop. So my convergent criteria could be that difference between all of the individual elements of a vector. So new one minus old one divided by old one, that's smaller than a number. Or I can simply do norm of a vector, like difference between two vectors, and divided by the norm of my old vector. So those are my options, yes?
Could you evaluate the answers for a particular equation and have that within tolerance?
No, because when I'm solving a new problem, I'm solving a new problem. So I could evaluate it for a different problem, but that's not necessarily the same problem as the one I'm solving. So I could test it on an example that I know, right? I have ax is equal to b. I simply give myself an x, find what a times x is, and that's my b, and then I go solve that, and I know what it is already, right? So in case that I have a solution, I can see how close I am to the true solution, but most often in realistic situations, I don't have that, that's why I'm solving. So in those cases, you're saying, okay, if two guesses in two successive iterations are close enough, I think I'm getting there. Okay? And if they typically, when we don't converge, that's called convergence. When we don't converge, it's going to blow up to an infinity or something crazy like that. So basically, this is, so you could either do norm of the two vectors, so norm of the entire vector x new minus old, divided by the norm of old. So that's an option. Okay. If you divide by norm of the new vector, same similar thing. I discussed that already with the root finding. Okay. So that could be the way to evaluate error, or this, if you want to check this within sort of a for loop, that's a little bit of a drag. Okay. So that's the way to stop the iteration. And this is actually a comment, so sometimes I just don't know whether I will converge and that whether I will get anywhere. if you remember fixed point iteration, x is equal to g of x for finding roots, what was the rule for convergence? Absolute of g prime of x had to be less than 1. Well, for matrices, it's a little bit more difficult to set that up. And you're just going to trust me that it's actually equivalent to so-called diagonal dominance. If I have a matrix where diagonal elements, so for each row, diagonal element in absolute value is larger than the sum of the other elements in that row, that's a diagonally dominant matrix. And for such matrices, I will converge. That doesn't mean that I will not converge for the others, but this is enough for convergence. So if I go back to that example that we did by hand last time, is this matrix here of coefficients, is it diagonally dominant?
Yes.
So I have 3. 3 is larger than 0.1 plus 0.2. Much larger. Great. 7 is larger than 0.1 plus 0.3. And 10 is larger than 0.3 plus 0.2. So this one should be. So now you know the theory. It's time to program it. So if you need a laptop, take a laptop from you. Yes.
So as far as the diagonal, so if you have 2 rows with the diagonal elements being dominant and 1 row with it not, would that not converge?
So it has to be for all.
So that one element has to be less than the sum of the rest.
That one equation will throw it off. Yes. So let's get.
That only for the Jacobi.
Hmm?
That only for the Jacobi.
That's for Jacobi method, yes. So that's for these iterative methods. So take a laptop if you need one. If not, work on your own. You can work in pairs if you want to. Dr. Gray, would you like a laptop? Just kidding. So open a new file. Can you remind me who are we playing on Saturday? I don't know. Anybody else? Kansas, what's the color? Blue and red. All right. Blue. Plenty of blue. Who has a blue shirt? Not you. So blue shirts are gonna be target since we don't like Kansas. Alright. So if I was programming, you can simply tell me what would be the first line of this. I want a function that I'm gonna call Jacobi iteration. So what am I going to write in the first line? So what is my output if I'm solving a system?
Whatever you want it to be. Like a bracket, you can put a letter in there, close bracket.
How about x? We always call it x. All right, x. And now I'm gonna give it a name. And my input will be what? It'll be matrix.
It'll be exactly that right there.
Matrix. Then what else do I need in my ax is equal to b?
Your B.
B. And this is an iterative method, so I need a starting guess.
Yeah, so your X naught.
X naught. There we go. We got the first line. Woohoo. Tolerance. Okay. She wants tolerance to be an input as opposed to being something. We can make it an input. So that's a design choice, right?
Yeah.
I could have hidden tolerance inside and just set it to some number that only I know, and the person using doesn't. So that's the case with most of the numerical software. Okay? It has some tolerance within that it's typically not telling you. Okay? And you look at the solution, and the solution looks pretty and colorful when you plot it, if it's like you're plotting pressures or something like that. And you're like, yeah, that's right. Okay? But there was some tolerance within that software that the software decided, okay, this is good enough now and I'm going to stop. So that's something for you to know in general. So we're going to actually take the tolerance. All right. So this is my function. And what did we say? So I'm trying to now program. Okay. And basically I wrote this very cryptic way, but what's nice about this is that basically it's one equation that gives me all of my x's. If you don't like that one, then you can go back to this slide, which actually had it like written out a little more specifically for every x and for y. But I want my system or my iteration to work for all systems of all sizes. So first thing that I will check is, well, what is my size of A, so I know what the size of my problem is. If I was very careful, and right now I will not be, I should also check the size of B and check the size of x0, and they should match my A, or else, right?
So you put that line green because you want it to work for all sizes.
Right now, yeah, right now I'm just checking the size because that will also, I need a for loop that goes from 1 to n, right? So let's say that like we will give it an input. So how about you work on your own, and Ningyu and I will walk around. But I basically want you to program. So I will have a for loop that goes from 1 to n and does stuff. And I also have to, outside of it, I have a while loop while my error is larger than tolerance. I gotta do this, right? So you now essentially have to fill that in. You have to initialize error to something so that you actually enter the while loop. And then you actually have to compute here. So this is your skeleton of the code that I expect you to fill in. Yes?
You just, instead of using a while loop, could you just use a for loop? And then in the for loop, you just say if the error is greater than 2, then I'll pick up this.
And break. Yes, that's equivalent. I quite frankly don't like breaking from for loops. But yes, so the same, if you want to do that, do that. Okay. So the similar idea would be do a for loop here. Okay. Maybe set some maximum number of iterations and do a for loop from 1 to that maximum. That is just gonna be doing that. Okay. So option number 1 is do this, and I guess setting maximum number of iteration is probably a very good idea. Okay, so let's say 10,000. Okay, so here I'm gonna say and my number of iterations. So iterations is first it starts with 1. Iterations is less than this maximum. So you can do this, and if you don't want to do a while loop, what you would do with a for loop for iterations is 1 to this maximum, okay? And you do then the rest within. But then you have to break if your error is smaller than tolerance. Is everybody clear? So you choose, okay, what you're more comfortable with.
So if you're old and your new values, if you have like k to the +1, that's not actual power, that's just a superscript.
That's just a superscript indicating, so this is like old, new.
Okay.
Okay. So here I would just, at the end of this, don't forget to increase number of iterations. So again, you have options here. Pick your favorite type of loop. And then when you're done with programming, I want you to test it with this system that we had here in the example. So this is the example to test it with. All right, so work on it a little, and we will walk around and help. That's very great. Now,
Oh, no, it'd just be I.
Yes, we did. Yes.
You don't have to. That's like your
It says J does not apply, but then it says if J is one, and it says I. So how does J not apply? J is the summation. J is one, so. So J is just here. So just yeah.
just be alive.
Think about all the questions. I think it was nothing for all the questions. So just
Why is it
Yeah, right now I'm just.
So you basically have to make like N-I-J. So right now I'm just kind of working on I don't know. I just want to make like a condition down there. I didn't talk about what it's here. I think it's condition. But each time it goes through, I'm just thinking, like, you can look at
Oh, sorry. Oh, you're right.
So now you're
They just call it execute and execute. I think she just did that because she has a subscript already on it. So she did that.
and not the only one. But so now I have my Bible works. Maybe that's a big deal. I mean. Okay, so this, yes. This has go up. What?
For this, would it be X on the side or there would be X? But then you're in, there's X. Even up here, X is X naught. So it needs to be numbered. And then it says like this will be in words.
So any error. So let me just.
I saw videos.
So did anybody get to computing the norms?
Wait, what norm?
Or error?
Oh,
How do you compute the error when you're done with the iteration? How do you compute the error at the end?
you take the.
Take what?
Either.
So you can have absolute values of each element, but I think the easiest thing would be the mistake of norm of your new and old x difference, norm of the difference divided by norm of the old,
Norm of the new, okay.
or norm of the new. Just let me write this down.
So like relative error?
So and use the function norm just to be quick. So error. So let's say that I'm calling these x's x and x0 and x, right? Is norm of x minus x0 divided by norm of either x0 or x, whatever you want. This won't work necessarily for your initial 0, so just use norm of x here. So that the initial zeros don't throw it up. You don't start dividing by 0. Alright? So use that as an error, and then I'm gonna answer the other questions. Just a second.
So then we did for this looks like your code.
This is from my homework, so I'm just gonna change this
Something zero.
Can you read It's all
Okay, I thought.
Alright, we're gonna go over this.
But it's not. Oh, alright, can you give me a hint?
No, this is good. This is different. This is a vector. You take norm and divide it by norm of x.
I like to take how many minus.
That's not the same.
Is that it?
So norm of the difference.
Okay,
Specifically
next problem.
because those vectors are flying very fast directions. And then you're not on a compare for I from one to n, use that name, just if I is different from j.
Okay. Try that again. I like that.
Or what you could do is take the entire sum and just subtract a of I for the answer. So if you're checking whether it's equal, you can check that it's equal. So how do you check if I is different from j? What does the relational operator?
Not equal to.
Not equal to is this. I not equal to j. Squiggly equal. Tilde equal. X naught is your initial. So in this, your X naught in your code is this X to the K. Okay? That's your old value, 0 value. And xk plus 1 is your new X. Okay, so it's time for me to start typing it up. Okay? So how do I actually type this up? Okay? If I'm computing every x of I, I'm computing it from this. I'm basically typing this sum. And there's this sum here that I don't have right now. I'm just going to say it's sum x divided by a of I. Okay? And let me compute that sum x. So it's a sum. I will need a small for loop. So I will first initialize sum to 0. And then for j is equal to 1 through n, if I is different from j, then add this sum x becomes sum x plus sum x of I j times x0 of j. Because this is my old x, my x to the k, if you will. And okay. And this actually has to be outside. Okay. Okay. So this is basically this typed up. Okay. For every I, I'm computing xi like this, and I had to have an additional loop in there to compute, and I need another end here. Okay. So this loop here computes this sum here. It's sum of all of aij times x of j, except that I have to exclude one, and that one I exclude by using an if statement. This is not the only way to do it, but this is one way to do it. Yeah?
That doesn't say.
I could sum them all up and then just subtract a of I times x0 I. Okay? So if you avoid having an if here, you sum them all up and then you subtract sum is sum minus a of I times x0 of I.
So iter and I, this iteration.
No, iteration has nothing to do with I and j here. Iteration is just number of iterations. I'm just. So this is all one iteration for computing vector x. Vector x has n elements, so I gotta compute them with a for loop. N. I called it n. I don't know what you called it.
It just happens that iteration and I is the same for every rod.
No. It's not. It should. This goes through 1 through n. This should just go through elements of the vector. Okay, one thing that I need to do here is recompute my error. This is what I suggested here. Error is norm of x minus x0 divided by norm of x. You could use norm x0 here as well. It's not a huge difference, maybe in a couple of number of iterations. It's just that if I started with an initial point of 0, then it would compute infinity here. Because I would divide by 0, so I'm trying to avoid that. Am I done? Is this loop ever going to end?
If the iteration is 10,000.
There's one more thing that I need to do. And you know that for root finding, update my x0. So now you can say x0 is x. I computed the norm, so. And keep going. So So this will stop when the while loop thinks that the error, not when it thinks, when it either finds error less than tolerance, or
So you don't need to put the x1 equals x above?
now MATLAB is underlining error here. Why? I didn't initialize it, so I have to define it with 1, and then it will probably be fine. Okay, so I'm gonna save this. Okay, are we ready to test it? I don't know if it's debugged all the way. Let's see. So I'm gonna use my A to be this 3 minus 0.1 minus 0.2. My second row is 0.1, 7 minus 0.3, and 0.3 minus 0.2, and 10. So that's my A. My B is 7.85 minus 19.3 and 71.4. Let me just check that I typed things correctly. So 3 minus 2.4 is 7. Yes, I did. Okay. So I'm typing up my A's and B's from here, from this system. So then I want X is Jacobi iteration of my A, B, X0. So I'm just going to put 0, 0, 0. And tolerance, 0.001. Oh, yeah. Okay, dimensions must agree. Norm of X. How about I initialize X as zeros of X0. So the problem is that by default, I think it's creating a row vector. And we have X0 as coming in as a column vector, so that might be an issue. Let's see. Possibly. Yep.
Wait, will you scroll up to your script? Like the x equals,
This? So this is initialize X to be the same size. So I think by default, since we're not defining it, it's just going to grow a row vector. And then when I do a norm, they're not the same size because one is a row vector and the other one is column vector. And that's a problem for using norm. I'm just curious what the number of iterations is. So I'm actually going to pass number of iterations out. Five iterations. That was quick.
wait.
Okay. Questions? What is the problem in your code, line 32? I can't answer it from here. There's a typo in your line 5.
Can you slow down a little bit? Why do you have to say that if that?
Because it says here, sum should be done over everybody except when j is equal to 1. So I got to test for that. It's also over here. If I was doing this, there was no element A11 x1 here. There's no element A22 x2, right? So I got to avoid it. And I avoid it with if quickly. This one?
What did you do when you said x equals 0, size x 0? Did you change anything else?
I just initiated x to also be a column vector of the same size.
Wait, when do you define I?
I just do a for loop, so I is defined in a for loop.
What did you use for x?
That's what I did. I did
What did you use for your x naught?
I started with 0, 0, 0, so I call the function. I call the function with a 0, 0, 0. So one quick question. So let's say that you're annoyed by this calling the function as 0, 0, 0, 0. How do I modify my code?
You initialize in 0. So
I remove x0 from input. I say x0 is zeros of n1. Yeah? I also set tolerance within the code and avoid user messing with it. Let's go a little smaller. Okay? So now I don't have to initialize, I always initialize with 0. I take that away from the user. So that is design that is on you. Okay? Or on me if I tell you in your assignment that you have to have an input, you have to have tolerances input. Okay?
wait, x naught would our input x naught.
You could also say, well, okay, if user gives it, great. But if user doesn't give it, so if number of arguments is less than 3, you set it within the code. Is this clear? So if number of arguments coming into the function is less than 3, so user provided only first 2, okay? Then set x0 to 0, set tolerance to 10 minus 6. So you could go both ways. So this gives like a much more flexibility, right? I could call the function with 2 or with 4 arguments. Clear? This part? It's kind of neat. Yeah. All right. I will open an assignment, upload this code by the end of the evening. Okay, Jacobi iteration.